Hello, this is Kushagra, student number 240020, and this is my CMP 501 project demonstration video. Let's start the server using this server exe. We have a choice of using localhost or connecting two devices together. So if we want to connect two devices together, we will say no to localhost and enter the IP of our server or the IP we want the server to be on. Uh, or you just use the local host. And let's just resize this. And now let's launch a client. Let's go to client, client.exe. Yes, we want to connect to the localhost server, and we can see that client has connected. And then just press Y to play. And this is our client now. We can dock it to the side. Yeah, this is a bit stretched. Uh, we can launch the client again. Press yes again, and get this to the side as well. So now we have two clients with their positions being correctly updated. They can shoot, and the bullets can collide with each other. So if I want, I can shoot this client there, and we will see that the player health is 80. The server says player 2 bullet hit player 1, and this enemy health is 80 now. So I can shoot it again, and we'll see it happening again. So as soon as the bullet reaches that player, we have enemy health as 70, and then the player health updates to the next player as 70. The server says again, player 2 bullet hit player 1. The same is applicable on the other side as well. So if player 1 hit player 2, the respective healths will be decreased. Apart from that, we have the controls over here. So we can press Q to quit. And when we quit it, one of the clients will say enemy forfeited, you won because somebody quit. And the other one will say you quit, game lost. If we want, we can play again and then press Y again. Uh, we can do the same with the other client, play again, press Y again, and the game will now start again. The goal of the game is to kill the other player. So if I fire 10 bullets, uh, this will die. It died. And then the loop comes again. So you kill the enemy, you won, you can play again. And for the other one, you died, you lost. Now let's see how it performs under poor network conditions. So let's start with lag, and let's have an RTT lag of 200, so which means a single lag of 100. And if I launch the game now, uh, right off the bat, we see that the press Y to play PacketPew message was a bit delayed. So it is a bit delayed. We can see that there. And in the server code, we can see the relay enemy join was a bit delayed. And here, if we move, this is a bit delayed. However, it's playable. It's not really horrendous. Also, the bullets, yep, they are a bit delayed, but like I said, it's not horrendous. It is playable. The collision is still working because that will not affect the lag will not affect the collision. It's just the message will be received a bit later. That's all. If we make the lag a bit more, so let's say 150 ms, so that's 300 RTT ms. Um, and this is on borderline unplayable because you can see the positions are being updated so late. In fact, there can be a case where this player fires a bullet and on his screen the player is here, whereas in reality the player has moved. So we can have that case of, oh, I shot you on my screen, but uh, you simply didn't because I moved. Uh, let's try packet drop. So let's try drop of 10%. And now we will see the player movement being a bit choppy. So we can see that it is not as smooth as it was earlier. And the bullets are also dropped. So, okay. So if I fire a lot of bullets, you can see there was a bullet which is dropped. Let's do it again, and we can see there is a bullet which is mistimed, and all of that is because of our drop. If I increase this to, let's say, 25%, now this will become more rough. So you can see the the enemy motion is a, a lot choppier, and we can see the prediction working. So we can see the prediction interpolation working. So the enemy is trying to keep up, but the lack of data is making it suffer. For the bullets, we will still have, we have a lot of more bullets which are just not being registered. Some are going in the other way because bullet depends on the player rotation. And since the packets are being dropped, the player rotation is being dropped. And if there is wrong player rotation, so you can see I was looking in the other direction, but the player fired in the other direction on the enemy screen, and that made this player very unhappy because it got shot. We can, if we increase it further, so let's increase it to 35%, and this will become unplayable. So you can see here that's just it's just broken. So yeah, this is how the application performs under poor network conditions. Uh, this can be fixed using several techniques such as callback for lost packets and using UDP when there is lag. So if we use UDP, when we will use UDP, um, the lag will be a bit less since UDP is a bit faster than TCP. The detailed testing results can be found in the report with all of the metrics that are tested for the application. The bandwidth is remaining, so let's try bandwidth now. So let's start with bandwidth of 200 kbps, and we click start. And if we open up our applications, we can see it's working. So 200 kbps is all right. And if we go further below, let's go to 100 kbps. And this is fine as well for both the clients. And if we go even further below, let's go to 80. And this works as well. If we go below, let's say 50, this will lead to failure because the client cannot send the message anymore. It's too big. And if we see the command line, we'll see that we were we were not able to send the live check as well. So that closed the networking thread, and that in turn crashed the application. So the application does not perform very well for bandwidths less than 80 kbps. If I talk about the code, um, the client starts here with the choice of if you want to connect to localhost, and yeah, some error checks, and then we have the game loop, the game do while loop. So we are calling this main game function if we want to play, and then main game function will take care of our player rendering, enemy rendering, player bullet rendering, enemy bullet rendering, and network packet processing and input and health system. Whereas on a parallel thread, we have the networking. So if we go into networking thread.cpp, this is the implementation of networking, and these are the shared variables between them, between networking thread and the main thread. We also have a mutex to get that lock before we change any data, because if we do not lock it, then we'll have concurrency issues and deadlock issues. And this thread takes care of server live check and sending the packets that needs to be sent. So for example, the action packet, the firing packet, and receiving the packets from the server. So we're receiving enemy fire, we're receiving player position, we're receiving number of enemies. This is how a client works. For the server, we have the same thing in the starting. So we do if you want to use the local host or not. And then we have the selector loop where we wait for the client if selector is ready, and if we want to connect, we go to add clients method, which is going to connect the client, add it to our list, and add the IDs and sockets for this client data array, which is used to compare collision. This also contains this also contains locations, so that's more useful. And this also has the sprite, so that helps us getting the global bounds to compare the collision with the bullet. After that, we wait for the client if he wants to send something. If it does, we see what type of message it is. So if it's player playing, that's the first message the client sends. We relay that, okay, there is an enemy. We relay that to all the clients so they can update their enemy logic. There's also server live packet. We do not need to do anything in the server live packet. There's player action move packet, which is used to just store all of the inputs the player is doing, and we can then process those inputs based on a tick rate or based on a time. So we only process it 20 updates per second. And then once we process it, we can then send it back to our client. So once it's greater than our 50 ms time, we calculate the new positions and then we send it back to the client as player position. We also send these back as enemy position rotation to the other client. And this is how server works. So basically, clients input any movement, and then server receives that movement, put it into a list with a sequence number, and then every 50 milliseconds, it's going to go through that list, calculate everything, and then send it back to the client. Client will receive it. Based on the sequence number, will apply the motion. That's where prediction comes in. So if the client side receives a packet which says enemy position or player position actually, it's going to apply that position to our player. So if we receive player position, we apply the position to our player. So player set position is the new position which we received from the packet. And then we also have a list of actions we took on the client side with the sequence number. So if our sequence number is greater than the server's sequence number, so let's say we are receiving the output for sequence number 3. So we move the client to the sequence number 3 position that we receive from the server, and then we apply every sequence after 3. So we apply sequence number 4, 5, 6, and then we just wait for those sequence numbers to arrive. We also remove that sequence number from the list. For enemy prediction, we get a move direction from the server and we know the speed. So multiplying those will give us the velocity. And once we receive the packet, we receive the direction, we receive the position, and if the position is not same as the last position we have of the enemy, we assign the position. But if it is the same, then we know, okay, so this is the last packet, and I'm already here, so I should stop predicting now. And there we go, and we reset the move direction. When enemy is being drawn, we predict the position using move predict function. Now, move predict function, like I said, is just multiplying the direction with move rate or move speed, and then we draw with this predicted position and some linear interpolation. So this makes sure that when we shift to the enemy position, we are not jumping. Instead, we are smoothly going there. Once you quit or lose or win, there are these functions that take care of the networking thread. So this set is running false, which which makes the networking loop just null. This is not going to go over this and do the networking things because we are not playing. This also sets socket to true because then we can connect if there is even a tiny bit of response time from the server, and if the socket is false, this is going to give us error because the connect function will immediately return. We also disconnect the socket so that we can connect again. So this is all about my project. Let me know if you have any other questions or any other areas that I should explain. Thank you for watching.